We'll discuss next the Laplace equation. So, sinabi natin nung una that, diba, Laplace equation can be solved in Cartesian, cylindrical, or spherical coordinate system. So first, let's discuss Laplace equation in Cartesian coordinates. So, Cartesian. So, class, ano lang muna tayo? Simplihan lang muna natin. Gawin nating 2D. Two-dimensional. So, XY lang muna. Okay? So, let's recall, class, that ano yung Laplacian? Del squared V equals 0. This is the Laplace equation. So, in Cartesian, we get partial squared V partial x squared plus partial squared V partial y squared equals 0. So, now class, this is partial differential equation. So, how do we solve this one? So, ang trick dyan class is, let's assume a solution of the form. So, meron tayong v of xy. So, v of xy equals x of x, some function of x, and some function of y. So, x of x, y of y. So, ito yung ansatz natin. We call this the ansatz. So, parang guess. Actually, ina-assume natin na ganito yung form ng v of xy. So, let's label this equation 1. Let's label this equation 2. Now, insert natin yung equation 2 sa equation 1 to get partial squared x, y, big X to over partial x squared plus partial squared xy over partial y squared equals 0. Tapos class, di ba partial x? So it means hindi siya mag-a-act sa y. Okay? Kasi y is function lang siya ng y. And same here, partial y, ito hindi siya mag-a-act sa x. So we will get, next page, y d squared x. Class, gawin na natin siyang total derivative kasi, ayun, sa x na lang siya nag-act. Plus big X, d squared y over dy squared equals 0. So now class, what we'll do is, divide natin both side by xy. So let's divide them by big X, big Y. So we will get 1 over x d squared x dx squared plus 1 over y d squared y over dy squared equals 0. So class, this term dependent only on x. This term dependent only on y. Okay? So class, if titignan nyo to, this one, changing to, di ba? Kasi dependent on x. Ito, dependent din sa y. Dependent on y. Pero, they will always, the sum is always 0. So class, para ma-satisfy itong equation na to, ang kailangan is, this one is a constant, and this one is also a constant. Okay, class? Kasi varying to, supposedly varying to. Ito din varying. So, dapat yung right-hand side varying din, di ba? Pero hindi, 0 yung right-hand side. So, mangyayari lang to kapag constant tong dalawa. So, isulat natin. 1 over x, 1 over big X, t squared x over dx squared equals negative 1 over y, d squared y over dy squared equals constant. Let's say k squared. Okay? So, now class, bakit k squared? Bakit hindi na lang n or k? Later on, makikita natin na convenient siyang isulat as k squared. So, let's solve the first differential equation sa x. So, we have d squared x over dx squared equals k squared x. So, class, i-mental nyo na lang to I exponential. So, we have x of x equals a e raised to kx plus b e raised to negative kx. So, letter B. Yung sa y naman. D squared y ay over dy squared equals negative k squared y. 'Di ba? Negative na siya. So, ang solusyon nito class ay hindi exponential kundi sine and cosine. So, this is, so y of y equals c sine ky plus d cosine ky. So, now, ang general solution natin ay v of xy equals x of x, y of y. So, this is equal to a, gawin natin bracket, a e raised to kx plus b e raised to negative kx times c sine ky plus d cosine ky. Yan. So, class, ito yung general solution natin. Then, paano malalaman yung constants A, B, C, and D? Tapos may K ka pa na constant, di ba? Yan na yung may indicate ng boundary value problem natin. So, sample problem tayo. So, example, we have two infinite grounded metal plates parallel to the XY plane. Medyo mahirap to. So, meron tayong XYZ. X, Y, Z. Sabi, may isang grounded, take note class, grounded infinite na grounded, then may isa ring infinite na grounded dito sa taas. So, dalawa sila. Ay, gandaan ko. So, parang ganyan. Two infinite na plane parallel sa XZ. Tama. Parallel sa XZ plane. 1 at Y equals 0. 1. Ay, sorry. Parallel plus sa XY plane. Parallel. Teka lang. Para mas malinaw. Meron tayong X dito. Y dito. Kasi iba yung nasa problem class. Okay, consistent ba ito sa right hand rule? X, teka lang class iniba ko yung coordinate system natin. X cross Y equal pa sa Z. So, ayan. Y cross Z. Tama naman. Consistent naman siya sa right hand rule. Okay. So, ang sabi, meron tayong two infinite grounded metal plates parallel to the XZ plane. Tama na. So, 1 at Y equals 0 and 1 at Y equals A. So, next at X equals 0, eto, the potential is maintained at V naught of y. Nasaan class ang x equals 0? Itong yan, di ba? At x equals 0, v equals v naught of y. So, dependent lang siya sa y kasi constant yung x equals 0. So, find the potential inside. So, the task now is find the potential inside the quote-unquote slot. Dito sa loob ng parang dun sa sandwich ng parallel plates natin. So, take note v equals 0 sa upper limit, v equals 0 sa lower plate. So, class, recall lang natin yung solution kanina. In general, v of xy equals a e raised to kx plus b e raised to negative kx c sine ky plus d cosine ky. Class, so now, ano ang ating boundary conditions? 1, v equals 0 at y equals 0. Tama. Number 2, v equals 0 at y equals a. Number 3, v equals v naught of y at x equals 0. Class, may isa pa actually. Number 4, v equals 0 as x approaches infinity. So, yun yung ating boundary conditions. Saan nanggaling class tong 4? Previous. Meron kang initial na potential dito sa x equals 0, di ba? Siyempre, pag lumayo ako ng gusto dyan, 0 na yung potential ko, di ba? Kasi 0 naman yung potential sa taas at baba. So, wala silang bearing sa infinity. Okay, so now we'll solve this using the boundary conditions. So, BC1, boundary condition 1, we have v of x comma 0 equals a e raised to kx plus b e raised to negative kx times, ano yun, c sine 0, 0 plus d cosine 0 plus d. So, bali d na lang to. So, d. So, we get either this is 0 or d is 0. Eh kung 0 to class, edi 0 na yung v of xy natin, di ba? So, hindi pwedeng 0 to. Therefore, d equals 0. So, class, update tayo. So, update, we have v of xy equals a e raised to kx plus b e raised to negative kx c sine ky. Okay. So, now class, apply natin yung boundary condition 2. Ang purpose ng boundary conditions ay para ma-eliminate yung unknown coefficients A, B, C, D natin. So now, boundary condition 2, v of x comma a equals 0 din. So, a e raised to kx plus b e raised to negative kx times c sine ka equals 0. Again, bawal tong maging 0 ha. So, ang 0 lang, ito. Actually, hindi kasama yung c. Kasi kung kasama yung c sa 0, wala na tayong solution. So, sin ka equals 0. Okay? Sin ka, pangit. Sin ka equals 0. So, kailan class to nasa-satisfy? Kapag k equals n pi over a, where n equals 1, 2, 3, dot, dot, dot. So, yun class. Na ano nyo ba? Kasi kung n pi over a ang k, so bali nasa loob is n pi. So, sin n pi, always 0 yan. So, may value na tayo for k. n pi over a. N runs from 1 to 3. So now class, isi-skip ko yung boundary condition 3. Maya na natin yun gamitin. Boundary condition 4 muna tayo. V of infinity, comma y equals a e raised to infinity plus b e raised to negative infinity c sine ky equals 0. So, e raised to negative infinity, 0 yan. So, ito, hindi pwedeng 0 to. So, bale, this one, e raised to infinity equals 0. So, class, kailan to mangyayari? Kapag a equals 0. Okay? So, update tayo. We have v of xy equals b e raised to negative kx c sine ky. Where yung k, alam na natin kung ano yun. So, now, class, constant lang to, di ba? E di, i-ano na natin, pagsamahin na natin, and i-simplify na natin yung k. So, this is c e raised to negative n pi x over a sine, naririnig nyo ba yung pusa sa kapitbahay? Ako naririnig ko eh. N equals 1, 2, 3, dot, dot, dot. Okay. So, yan yung v of xy natin. So, class, di ba n runs from 1 to 3? Sige, simplify pa ulit natin to further. So, let's construct a more general solution na lang. More general solution. So, actually, class, ang v of xy ay infinite sum. Summation n equals 1, positive infinity, ng c sub n e raised to negative n pi x over a sine n pi y over a. Yan yung ano natin, mas general na solution kasi tinake into account na natin itong maraming n. So, yun lang. And then, gamitin na natin yung boundary condition 3. So, the question now is, how do we get Cn? How to get C sub n? Yung unknown coefficients natin. So, we will use another boundary condition. So, boundary condition 3. So, recall natin that v of 0y equals v naught of y. So, ano na to? So, some function of y. So, bale, summation n equals 1, positive infinity, c sub n e raised to 0. 0 yun, di ba? May x doon. Sine n pi y over a. Ang ingay ng pusa sa kapitbahay. Naririnig ko sila. Equals v naught of y. So, bale, summation n equals 1, positive infinity, c sub n sine n pi y over a equals v naught of y. So, class, medyo, ano na. So, yan ba yung value ng unknown coefficients natin? Actually, meron pang further way para malaman yung Cn. So, class, naalala nyo sa 1-to-1 yung Fourier series? Sige, alalahanin nyo. Then, gagamit tayo ng Fourier trick. So, gamitin natin, tawagin natin siya as Fourier trick. So, ang ginawa natin doon, so, alalahanin nyo lang sa 1-to-1. So, multiply by sine n prime pi y over a, both sides, then integrate from 0 to a. So, katulad lang to actually nung ginawa natin sa Fourier series sa 1-to-1. So, Let's see kung paano siya mag-work. So, summation equals 1 positive infinity. Diba ang sabi, multiply. So, Cn, sin n pi y over a sin n prime pi y over a. Tapos, this is equal to, ba't nag-e-erase? This is equal to v naught of y sin n prime pi y over a. Then next, integrate from 0 to a. So, integrate from 0 to a. So, ano to? dy. Integrate from 0 to a. 0 to a dy. So, class, identity to ng integrals. So, 0 to a, ginawa nyo na to dati. So, hindi na natin gagawin ngayon. Sin n pi y over a sin n prime pi y over a dy equals a over 2 Kronecker delta n prime. So, yung Kronecker delta 0 if n equals n prime, 1 if n equals n prime. This is 1 if n equals n prime, 0 if n not equal to n prime. Okay, so now, ano na yung, tingnan ko nga ulit yung ano natin kanina. So, we will get ito, summation n equals 1 positive infinity Cn a over 2 Kronecker delta n prime equals integral ng v naught of y sin n prime pi y over a dy. So, this is non-zero for n equals n prime, di ba? So, bale, the rest ng infinite sum natin, 0 if n equals na, if n is not equal to n prime. So, ito ay non-zero for n equals n prime. Therefore, yung n equals n prime na term, yun lang yung magsusurvive. So, value, we have Cn prime a over 2 equals 0 to a v naught of y sin n prime pi y over a dy. So, ang pangit na index ng n. So, drop natin yung index. So, drop the index. Gawin natin from n prime. Balik tayo sa n. So, we have Cn, Cn a over 2 equals integral 0 to a v naught of y sin n pi y over a dy. Therefore, Cn now equals 2 over a integral 0 to a v naught of y sin n pi y over a dy. So, finally, we have our v of xy, yung potential na hinahanap natin in the first place. This is summation n equals 1, positive infinity, 2 over a, yun yung Cn natin, integral ng 0 to a, v naught of y, sin n pi y over a dy, e raised to negative n pi x over a sin n pi y over a. Nga ba? Kasi class, ito lang yung Cn. Ay, kulang pa ng bracket. Ay, kulang ng bracket. Okay. So now, ito na yung complete solution actually. Pero bakit mukha siyang hindi simplified? Kasi yung problem natin, class, general yung potential dun sa gilid, yung v naught of y. So, further example, what if v naught of y equals constant. Gawin lang natin constant, class. V naught. So now we get v of xy equals 2 over a summation n equals 1 positive infinity 0 to a v naught, constant lang yan, sine n pi y over a dy e raised to negative n pi x over a sine n pi y over a. So, class, this is, ano ba to? Tigrit nga muna natin to. This is v naught, negative cos theta. So, negative v naught cos theta, cosine n pi y over a over n pi. So, this is a over n pi, running from 0 to a. So, this is equal to negative v naught a over n pi cos n pi minus cos 0, 1. Ayan. So, class, ano ang cos n pi minus 1? Ang cos n pi minus 1 ay equal sa 0 if n is even and equal siya sa negative 2 if n is odd. N is even, cos 2 pi, so 1. Cos 4 pi, 1. Cos 6 pi, 1. 1 minus 1, 0. So, n is odd naman. Cos pi, negative 1. Cos 3 pi, negative 1. Cos 5 pi, negative 1. So, negative 1 minus 1, negative 2. Okay? So, 0 siya for even terms. Then, negative 2 siya for odd terms. So, bale, v of xy now equals 2 over a. 2 over a summation n equals 1 positive infinity negative v naught a over n pi times negative 2 e raised to negative n pi x over a sine n pi y over a with the emphasis that n is odd. Therefore, now v of xy equals ano to? For v naught over pi summation n equals 1, 3, 3, 5, dot, 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 1 over n, e raised to negative n pi x over a sine n pi y over a. Yan na yung v of xy natin. Unfortunately, infinite sum pa rin siya. Pero yan na yung final na result. Okay? So, ano ang takeaway dito sa Laplace equation in Cartesian coordinates? Step 1. Solve the Laplace equation to get the general solution. Step 2. Apply boundary conditions. Then, step 3. Use the Fourier trick. Okay? So, ito lang yung summary ng mga ginawa natin actually. Then, that's it for Laplace equation in Cartesian coordinates.